Good day, sir. Good day, everyone. And welcome to MTEC 102 Midterm Period, Week 2, Session 4. And our topic for today is Application of Error to a Compass. So together with my team, Decadet Larra, Justine COGTAS, Decadet Lynn GEONZON, and me, Decadet Cecilieto Jr., let us proceed for the learning outcome of the topic. The first learning outcome is that at the end of the session, the students shall be able to learn about the deviation. Second is at the end of the session, the students shall be able to know the advantages and disadvantages of gyro compass. And for the course outcome, the students will understand the application of error to a compass as well as knowing the importance of the topic. For the importance of the topic, a gyro compass is a form of gyroscope used widely on ships, employing an electrically powered, fast-spinning gyroscope wheel and frictional forces among the other factors, utilizing the basic physical laws, influences of gravity, and the Earth's rotation to find the true north. Next, there are a number of reasons why the compass division is affecting the steering compass. So, it is due to the onboard magnetic influences, such as magnetic items, items to which magnets are attracted, wires carrying DC electrical current. Second is to reduce the effect as much as possible. So, by keeping away the compass from such influences and twisting the nearby DC wire pairs. For a quick trivia, did you know that deviation is often greater than 10 degrees? Special magnets or compensators are installed in compasses to reduce error, and most compasses comes with instructions. And lastly, you can still have significant deviation error after the compensations. So next will be computing of the compass errors or computing of the compass corrections. So we will be using the TVMDC. So T stands for true heading, V variation of chart, M is magnetic heading, D division, and C is compass course. So in the first tier, it is also known as the two Virgos make the company, where the solving for each blank value will be answered through adding the values of the variables given to us. So to better understand the topic, here is the illustration.
True virgins make doll company. Add whiskey, subtract ethics. No one ever forgets that. Don't know why. So, this T stands for true, right? True. Variation. Where you are on the planet, right? Where are you on Earth? Magnetic. This is a middle step. You'll see this. This is the inner compass rose. Compass roses on charts. There's the outer rose, which is true, right? Outer rose, it has a star, it's true. Then there's the inner rose. It has an arrow that has variation built in it, and this shows this is the magnetic rose. Deviation. Deviation. This depends on your heading. Certain pieces of the vessel, certain parts of the vessel, the battery bank on a steel vessel, where you keep your tools, where you put your cell phone, these things create deviation. And this bottom one is compass. Compass. On navigation problems, we see this in degrees PSC, right? Degrees PSC, and this is degrees true. Degrees true has no error in it. It's geographically true. If you put variation and deviation in it, you get your compass from your ship. The compass on your ship has a certain spot on the planet that throws it off, variation, and certain characteristics, the magnetic condition of your vessel, which in turn makes your heading, right? Your compass wants to point north. Your vessel rotates about your compass. There's certain things on your vessel that are affecting your compass. So as your heading changes, those certain things on your vessel that affect your compass move around your compass and affect your compass. Deviation. So we are going to do problems where we take degrees true and work them. We put variation and deviation in them and get compass. We'll do other problems where we have compass degrees. We take deviation out, we take variation out, and we get true degrees. And we'll have to work between these two things to solve compass problems. Start with 45 degrees true. And here's our deviation table. We have to read a deviation table coming at you. Here it comes. Deviation table. See that at the bottom? It says variation. Block Island, use 15 degrees west. See these different columns? So heading of 0 gives a 2 degrees east deviation. Heading of 30, 3 east deviation. 60, 4 east variation. 90, 2 east variation. You will find this deviation table under topic 3. There's a PDF that says deviation table. This is what you get, this deviation table here. And we get heading. For each heading, it gives us a deviation. Remember? Deviation, this step. So if we start out, we look on our chart and we get a true course of 45. Right? Well, we need to know, okay, we know on the chart it's 45 true, but what do I steer on my vessel accounting for variation and deviation to get compass? So let's look at that. 45 degrees. It said variation on Block Island is 15 west. Right? If you look in the center of Block Island compass rose on the chart, it says 14 something, 14 something, with an annual change of 6 minutes. Right? 60 minutes in 1 degree, so it takes about 10 years for it to change 1 degree. All these problems are from 1983. And the reason we use 15, the Coast Guard in 1983, when solving these Block Island problems, used 15 west variation on every problem. So if you use that, you can get the right answers too. So 15 west variation. Again, on your deviation table, you see it? Block Island. Use 15 west variation. We're not going to use Chesapeake Bay, just Block Island. So 45 true. We know the variation is 15 west. When we go down from true to compass, we add west. 45 plus 15 is 60 degrees magnetic. A deviation, now we need a deviation, right? Go to the chart. 60 degrees, what does it say? 60 degrees is 4 east deviation. 4 east. It's very important that you know if it's east or west, because that says if you add or subtract. So it's 4 east, we subtract, we get 56 degrees PSC. This is the label you will see when we're dealing with compass. So again, 45 true. We're on Block Island, so our variation is 15 west. It stays that way, which gives a magnetic of 60. Go to the table. Deviation of 4 east, which yields 56 degrees PSC. Now, this is where it gets interesting, right? I said that we can either put variation and deviation in to get compass. Well, we can also start from 56, take deviation out, take variation out, and get true. So if it switches, right? So 56 plus 4 east is 60, minus 15 west is 45. So we started with 45. 45 plus 15 west is 60, minus 4 east is 56. Well, when we go the other way, there's another mnemonic rhyme you can use if you'd like. Can dead men vote twice at election?
So that would be all for my topic. The next reporter will be Decadent Larra COGTAS.
Isogonic chart is a chart showing the distribution of one of the magnetic elements, such as by isogonic lines. So this is the example of the isogonic chart. Back to measuring deviation. For each 15 degrees to 30 degrees, you need to know what direction magnetic your boat is pointed. Second, compare with compass reading. And third, compute deviation. Key to puzzle is knowing exactly what direction you're headed. Example way to know your heading. First is remaining in vicinity of ATO. Second is record both compass heading and relative bearing every 15 degrees to 30 degrees. Third is compute deviation for each heading. Measuring relative bearings. Mounted parallel to vessel's keel with all-around view. 0-degree aligned with keel. Align targets in sights. And lastly, read relative bearings on scale. The next reporter will be Decadent Johnson Angeline.
Hi, I am GEONZON Angeline. So for the next topic is about shipboard compasses. So the gyro compass has three axes. We have the spin axis, the torque axis, and the precision axis. Next is the advantages over the magnetic compass. So first, it seeks true or geographic meridian instead of magnetic meridian. Next is it can be used near the Earth's magnetic poles where the magnetic compass is useless. Next is it is not affected by surrounding material. And last is its signal can be fed into inertial navigation system, automatic steering system, and fire control system. And next we have the disadvantages of gyro compass. So first is it requires a constant source of electrical power and is sensitive to power fluctuations. And last is it requires periodic maintenance by qualified technicians. And the next is if the gyro compass bearing is higher than the actual bearing, so the error is west. And next is if the gyro compass bearing is lower than the actual bearing, then the error is east. So we have the quotation, or we are familiar by this, that compass best error west and compass last error east. So that would be all, and thank you for listening.